The equation of a general straight line. The straight lines that we've studied before have all passed through the origin. We now explore some lines which are not restricted in this way. Previously, we met y equals mx, where m represents the slope or gradient of the line. Now we extend this to equations having the form y equals mx plus c, where c is a number indicating where the line crosses the vertical or y-axis. A general straight line can be represented by an equation of the form y equals mx plus c, where m and c are known fixed numbers or constants. The values of m and c can be positive, negative, or zero. Each of the following equations is of this general form: y equals 2x plus 1, y equals 3x plus 4, y equals minus 2x plus 3, y equals minus 7x, y equals minus 4x minus 9, and y equals 5 plus 3x. Comparing each of these in turn with the general form y equals mx plus c, we observe that in y equals 2x plus 1, the value of m is 2 and the value of c is 1. In the equation y equals 3x plus 4, the value of m is 3 and the value of c is 4. In y equals minus 2x plus 3, m is minus 2 and c is 3. In y equals minus 7x, m is minus 7 and c is 0. In y equals minus 4x minus 9, m is minus 4 and c is minus 9. In y equals 5 plus 3x, notice that the coefficient of x is now 3, so m is 3 and c is 5. We could have written this equation in the equivalent form y equals 3x plus 5. You will often come across equations written in seemingly different yet equivalent forms. You must learn to watch out for this. To plot a graph of these straight lines, in each case we need to know the coordinates of at least 2 points on the line. In fact, we shall calculate the coordinates of more than 2 points, because doing so serves as a check to ensure our calculations are correct. Suppose that points on a straight line are related by the equation y equals 2x plus 1. This means that for every point, its y-coordinate is found by multiplying the x-coordinate by 2 and then adding 1 to the result. For example, if x is 3, then y is 2 times 3 plus 1, which is 6 plus 1, which is 7. The coordinates of the point are therefore 3, 7. Similarly, if x is 4, y is 2 times 4 plus 1, which is 8 plus 1, that is 9. The coordinates of the point are therefore 4, 9. And again, if x is minus 2, y equals 2 times minus 2 plus 1, which equals minus 4 plus 1, which equals minus 3. The coordinates of the point are therefore minus 2, minus 3. It's common practice to store these values in a table as shown. You should complete the table for yourself. Sometimes you might find it helpful to split up the table to show the intermediate stages of the calculation, like this one. Either way, we now have the coordinates of several points, including -2, -3, 3, 7, and 4, 9. In the diagram shown here, these points have been plotted and joined to produce a straight line. Note that only 2 distinct points are required to define a unique straight line, but we've calculated a third point just as a check. If the 3 points do not lie on the same line, then we've made a mistake in our calculations. Do the other points you found in the table lie on this line? Check this now. It's good practice to label the line with its equation y equals 2x plus 1, as shown here. Notice from the graph of y equals 2x plus 1 that the value of c, in this case 1, gives the y value at the point where the graph cuts the vertical axis. We call this point the vertical intercept. It is always the case that the value of c in the equation y equals mx plus c gives the value of the vertical intercept. Knowing this fact helps us to draw the graph correctly.